Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam LTAM from the last exam MLC in spring 2018. For a fully discrete 20-year term insurance issued to a 35-year-old with face amount of $1 million, you are given that the annual net premium for this insurance is $3,489. Mortality follows the illustrative life table. Interest rate is 6%, which, by the way, is the interest rate used for calculating actuarial present values in the table used on exam MLC. The force of mortality is constant between integer ages. Calculate the net premium reserve at time 10.4. Well, the key issue, of course, is that the valuation is done at a fractional time between two policy anniversary dates. But we can still write the version of the recursive net premium reserve formula between times 10 and 10.4. So reserve at time 10 plus the premium paid at that time accumulated over 0.4 years at the valuation rate of 6% gives us the reserve for those who live and a probability of living at age 45.4. So 0.4 of a year into that year is 0.4 P45 times the reserve at time 10.4 plus for those who die, the probability of dying is 0.4 Q45. A million will be paid, a million death benefit will be paid at the end of the year. So we need to discount that payment from the end of the year to time 0.4 by multiplying it by 1.06 to the negative 0.6. From the illustrative life table, Q45 is 0.004, so that P45 is 0.996. Now the force of mortality is constant between integer ages, so if we write mu for that constant, px is e to the minus mu, and for fractional t we have tpx equals e to the minus mu t, which is the standard constant force formula. That's something that you should definitely remember. And that's of course equal to px to the power t, because px is e to the minus mu. So 0.4 p45 will be p45 to the power 0.4 or 0.996 to the power 0.4. Also, the reserve at time 10 is the actuarial present value of future benefits, and future benefits are paid over remaining 10 years, and it's actuarial present value of term insurance for those 10 years on a 45-year-old, minus actuarial present value of future premiums, which is 3489 times a double dot 45 colon angle 10, because the premiums will be paid as long as this 45-year-old is alive, but only for 10 years, up to 10 years. And we can find the values that we need for this from the illustrative life table. First we have a million times a 45 colon angle 10 with 1 above 45. That's 1000 times 1000 A45 minus 10 E45 times 1000 A55. And then from the illustrative life table we can find all these values. 1000 A45 is 201.20. 10 E45 is 0.52652, and A55 is 1000 times A55 is 305.14. So once we plug that all in and calculate, we get that actuarial present value of future benefits to be 40,573.6872. And the actuarial present value future premiums, 3489 times A double dot 45 colon angle 10, that's 3,489 times A double dot 45 minus 10E45 times A double dot 55. And we can find these values from the illustrative life table. So A double dot 45 is 14.1121. 10E45 is 0.52652. And A double dot 55 is 12.2758. We plug those in, calculate, and we get 26,686.1251. And then the reserve is the difference of the two quantities we just calculated, and comes out to be 13,851.56, approximately. Slight. There are more digits after 5, 6, but we ignore them for now. So we round it to 13,851.56. Okay, so now we actually have that reserve at time 10. We can use it, plug it into the recursive formula, and we see that the only unknown is the reserve at time 10.4, and we solve it for that, and then do the calculation, and the reserve comes out to be 16,228.59, and that's answer E. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.